Okay, guys, let's begin our exploration of Chapter 8 here, Quadratic Functions, the Mighty Parabola. Okay, so we begin with the parent function, which is the f of x equals x squared. Now, this is different from what we just did, say exponential 3 to the x. See, notice it's not 3 to the x, it's x squared. Okay, and so here's our parent function, f of x equals x squared, and I've making an xy table here in the left-hand corner. And notice I pick values on either side of my y-axis, -2, -1, 0, 1, and 2. Let's evaluate a point, and then we'll fill in the rest. So say f of -2. I'm going to plug -2 in for x in parentheses and then square it. What's -2 squared? Well, if you said 4, you're correct, +4. And then -1 squared becomes +1, 0, 1, and 4. So if I were to graph this shape, I want to plot these points. 2, -2, 4, -1, 1, 0, 0, 1, 1, and 2, 4. And then I want to draw my shape. Now it's a U shape and not a V shape, okay? Okay, so that would be the shape of a parabola. F of x equals x squared. And eventually we'll go to f of x equals ax squared plus bx plus c. However, we're just going to start with f of x equal to ax squared, but in this case just x squared, with a being 1. And that's again what's called our parent function. Okay, and as part of our discussion, we want to start talking about some characteristics here of the quadratic function. This part of the parabola, as it approaches what's called the vertex, and the vertex is here at 0, 0. And you notice our vertex is our lowest point there, and it's going to be our turning point. Well, back to this purple line. This is said to be what's called decreasing. Okay, so as we're approaching from -infinity, it'll be decreasing, and say on this green side, as I go up this way, this is what's called increasing. So it's increasing on the domain of x greater than 0. And it's decreasing when x is less than 0. And at the vertex, it's neutral. It's not increasing or decreasing. And that's again called your vertex. Okay, we also want to add this idea of the axis of symmetry. Notice if I draw a line right on this y-axis, which happens to be the line x equal to 0, if I, say, folded the green part over and laid it on this other light purple part, then say if I folded it over this line, x equal to 0, then it would lie on that purple line. So that's what's called our AOS, or axis of symmetry. In other words, it goes right through the vertex, and it's a vertical line. But in this case, it's just a dotted line. It's just a line that we dot in to show that if I folded one side over along that line, it should lie on the other line there, okay? Okay, let's look at another parabola that we'll just draw and see if we can identify those characteristics we just talked about. Okay, so I went ahead and just drew a parabola here, and we're going to see if we can identify some ideas, like domain. Remember that corresponds to our x values, our range, y. And how about our x? Where is it increasing? And where is it decreasing? And how we would define those ideas. Okay, and where is, of course, the axis of symmetry? Well, where is it? This vertical line, x equal to -1, this dotted line. Okay. Okay, so how about we start first for our domain? Well, as this parabola goes up, it'll of course go left 2, and as it goes up here, it'll continue to go right, of course, here, and of course our graph exists in the middle, so we would call that all real numbers. How about our range? Well, let's look. Our graph is going to come down here and hit a minimum at our vertex here. Let's go ahead and just label our vertex. Well, where is that vertex at? Well, -1 on x and -2 on y, -1, -2. Okay, back to range. So our parabola is going to come decreasing down, hit the parabola, and go increasing back up. And it's going to have a minimum when it, say, opens up as this one does. So this minimum is at the vertex. So in other words, our y values are going to get down to the minimum and then come back up. So how would we define that as a range? Well, y is greater than or equal to -2, you got it, because it's going to get down to the parabola and then come back up. And it'll never get below, to the vertex and come back up. So it'll never get below that vertex, it'll only be above it. And so our range is defined as y is greater than or equal to -2. Okay, where is it increasing? Well, we defined before that when it's doing this kind of motion on the right side, that's we said was increasing. Well, how would we define that? Well, let's define it as a x value. When x is greater than how? Well, all values greater than -1. It'll be increasing. And how about decreasing? Well, we said before that this part of the parabola is decreasing. And so that's all x values on this side of the vertex, x less than -1. Okay, so our domain is all real numbers. Our range is y is greater than or equal to -2 because it will get down to -2 at our vertex here. It's increasing when x is greater than -1, and it's decreasing when x is less than -1. And notice it's neutral at the vertex, neither increasing nor decreasing. Okay,